The first breath of another world. 49 light-years from Earth, in the constellation of Cetus, a rocky world orbits a dim red star. Its name is LHS 1140b. And it just made history. For the first time, astronomers have confirmed an atmosphere around a rocky planet in the habitable zone of its star. This is not a gas giant. This is not a scorching lava world. This is a super-Earth, a world that could, under the right conditions, harbor life. The discovery marks a turning point in the search for our place in the universe. The atmosphere was detected not by the James Webb Space Telescope, but by a ground-based instrument, the Magellan Clay Telescope at Las Campanas Observatory in Chile. During a 6.5-hour observation in September 2024, scientists captured the transit of LHS 1140b across its parent star. They were looking for something specific. They found it. Helium. Escaping from the planet's upper atmosphere at tremendous speed. This telltale absorption signal confirms something humanity has dreamed of for centuries, that this rocky world, sitting in the Goldilocks zone of its star, is wrapped in a blanket of gas. LHS 1140b was first discovered in 2017 by the M-Earth Project, a robotic observatory designed to hunt for planets around small, cool stars. At the time, astronomers knew it was something special. It transited its star, meaning it passed directly in front of it from our point of view. This made it a prime candidate for atmospheric studies. But it took nearly a decade of observations, a global pandemic, and the rise of next-generation telescopes to finally confirm what scientists had suspected. The planet itself is a super-Earth, roughly 5.6 times the mass of our planet and about 70% larger in radius. It completes one orbit around its star every 24.7 days. Its year is shorter than a single month on Earth. But despite being so close to its star, LHS 1140b is not a hellish world. Its parent star, LHS 1140, is a red dwarf, a small, dim, cool star with only 18% the mass of the Sun and a surface temperature of just over 3,000 degrees Kelvin. The planet receives only 43% of the sunlight that Earth gets from the Sun. In fact, at the top of its atmosphere, the equilibrium temperature is around 230 Kelvin, that is minus 43 degrees Celsius. Cold, but not impossibly so. The composition of LHS 1140b has been a mystery that scientists have been untangling for years. Initial measurements suggested it was an incredibly dense iron world, with a core making up 75% of its mass. But as more data came in, the picture changed. Later studies revised the radius upward and the density downward. The current best model describes LHS 1140b as an ocean world, a planet where water makes up between 9 and 19% of its total mass. For comparison, water makes up less than 1% of Earth's mass. This has led to the remarkable eyeball planet hypothesis. Because LHS 1140b is likely tidally locked, one side always facing its star, the planet might look like a giant eyeball in space. The permanent day side could be a warm liquid ocean, while the night side would be covered in a thick shell of ice. And where those two meet, along the Terminator line, conditions might be just right for life. The atmosphere detected in July 2026 is dominated by helium escaping from the planet's upper atmosphere. This is what scientists call a hydrodynamic escape. The upper atmosphere is being boiled off into space by the star's radiation. But the presence of any atmosphere at all is significant. It tells us that LHS 1140b has a secondary atmosphere, one that was not present when the planet formed, but was created later through volcanic outgassing, comet impacts, or chemical processes in the planet's interior. This is the kind of atmosphere that could support life. Not a hydrogen-helium envelope like Jupiter, but a thin, geologically produced blanket of gases like the one that surrounds Earth. The discovery was made by a team from the Center for Astrophysics at Harvard and the Smithsonian, led by researchers who have been studying LHS 1140b for years. They used the Magellan Clay Telescope's high-resolution spectrograph to detect the helium absorption line during the planet's transit. The signal was unambiguous. After nearly a decade of searching, humanity had finally found an atmosphere on a rocky, potentially habitable world. Why is this such a big deal? Because out of more than 6,000 confirmed exoplanets, only a handful are rocky and in the habitable zone. And of those, only LHS 1140b has a confirmed atmosphere. The TRAPPIST-1 planets, which made headlines for their 7 Earth-sized worlds, have so far yielded no definitive atmospheric detections. The famous Proxima Centauri b, the closest exoplanet to Earth, is so close to its volatile star that any atmosphere it might have had would likely have been stripped away long ago. LHS 1140b is different. Its star is old and quiet. At 5 billion years of age, it has settled down into a stable, low-activity phase. This means the planet has had billions of years to develop and retain an atmosphere. That is a very promising sign. The discovery also represents a major milestone for the search for life beyond Earth. Astronomers have long known that the first step in finding a habitable world is finding an atmosphere. An atmosphere regulates temperature, protects the surface from radiation, and allows for liquid water to exist. Without an atmosphere, even a planet in the habitable zone is just a barren rock. Now, for the first time, we have found a rocky planet in the habitable zone with an atmosphere. The next step is to study that atmosphere in detail. What is it made of? Is there water vapor? Oxygen? Methane? These are the biosignature gases that could indicate the presence of life. The James Webb Space Telescope has already turned its mirrors toward LHS 1140b. Earlier observations ruled out a hydrogen-rich atmosphere, confirming that the planet is not a mini-Neptune but a true super-Earth with a high mean molecular weight atmosphere. The tentative detection of nitrogen in 2024 was another puzzle piece. Now, with the helium detection confirming an active, dynamic atmosphere, the case for LHS 1140b as a habitable world is stronger than ever. Looking ahead, future missions will focus on this world. The upcoming Habitable Worlds Observatory, currently in the planning stages at NASA, will be designed specifically to study planets like LHS 1140b. The extremely large telescope, now under construction in Chile, will have the light-gathering power to dissect the planet's atmosphere in unprecedented detail. But the most exciting part is what this means for the search for life. LHS 1140b is not just a scientific curiosity. It is a target. It is the best place we know of to look for signs of biology beyond the solar system. If life exists anywhere in the nearby universe, LHS 1140b is one of the most promising candidates to find it. Of course, we must be careful not to jump to conclusions. An atmosphere does not mean life. Venus has an atmosphere, and it is a hellish inferno. Mars has a thin atmosphere, and it is a frozen desert. But LHS 1140b sits in the Goldilocks zone of a quiet, stable star, with an abundance of water and a confirmed atmosphere. The conditions are right. The ingredients are there. For the first time in human history, we have a world that we can point to and say, this is a rocky planet, in the habitable zone, with an atmosphere. It is not a theory. It is not a simulation. It is real. It is there, waiting for us to study it. The detection of helium escaping from LHS 1140b is more than just a scientific achievement. It is a reminder that we live in an age of discovery. The universe is slowly revealing its secrets. With every transit, every spectrum, every photon that reaches our telescopes from a distant world, we come one step closer to answering the oldest question humanity has ever asked: are we alone? LHS 1140b does not answer that question. But it gives us the best chance we have ever had to find out. The first breath of another world has been detected. The next breath might be our own, as we stand on the verge of the greatest discovery in the history of science. The discovery of helium escaping LHS 1140b has another profound implication. It tells us that the planet is geologically active. For an atmosphere to persist for billions of years, there must be ongoing processes replenishing it. On Earth, plate tectonics and volcanic activity recycle our atmosphere. On LHS 1140b, something similar may be happening. A geologically active world is a world that can sustain a climate over geological timescales. It is also a world that might have a magnetic field, a crucial shield against stellar radiation. The red dwarf LHS 1140 poses an interesting challenge. Red dwarfs are known for their flares, massive eruptions of radiation that can strip atmospheres from nearby planets. But LHS 1140 is unusually quiet. It rotates once every 130 days, and its magnetic activity is minimal. This is why LHS 1140b has been able to retain its atmosphere over billions of years. The star is gentle. And that gentleness may be the key to habitability. What would it actually look like standing on the surface of LHS 1140b? If the eyeball hypothesis is correct, the view would be spectacular. On the day side, a vast ocean stretches to the horizon, warmed by the constant red glow of the star. The star itself would appear much larger in the sky than our sun, a deep crimson disk, casting a dim, warm light. The sky would be hazy, filled with the gases of the planet's thick atmosphere. On the night side, everything is frozen. A shell of ice, kilometers thick, extends into the darkness. The boundary between these two worlds, the terminator, would be a ring of perpetual twilight, where liquid water meets ice, where the temperature is just right. This is the kind of place where life could emerge. On Earth, life began in the oceans, near hydrothermal vents, in environments that were warm, wet, and chemically rich. LHS 1140b, with its vast ocean, its thick atmosphere, and its stable, ancient star, may offer the same conditions. The search for life on LHS 1140b will not be easy. Even with the most powerful telescopes, detecting biosignatures in the atmosphere of a planet 49 light-years away is pushing the limits of technology. But the tools are getting better. JWST can already detect the composition of exoplanet atmospheres. The next generation of telescopes, the Extremely Large Telescope, the Giant Magellan Telescope, the Habitable Worlds Observatory, will be able to search for oxygen, methane, and other potential signs of life with unprecedented precision. The universe is out there. And now, we know that at least one other rocky world in the habitable zone is breathing. The search for a second Earth has begun in earnest. And LHS 1140b is leading the way.